Hello and welcome to this video where we'll be doing more leetcode. So yesterday I tried to record a video but my OBS wasn't working, so I'll just show you or tell you the problems I did. So I did range sum query. It's basically this one where it's unlike other leetcode problems. So you split it up into a constructor and a member function of a class. So basically the problem is that you want to find the sum in the range. And the way you can do this is with prefix sum. Then there was also counting bits, which is the one I said I would... Wait, no, was it? The one I said I would come back to was... let me see. I don't think it was that one. That was manipulation. Oh yeah, that was coin change, the one I wanted to come back to. So I figured out that and just went through it in my head, well, and on paper. So I did bit manipulation, max subarray. I did climbing stairs, which is basically just Fibonacci. Counting bits, which was it was a pretty easy solution because it's all to do with power of twos. Then yeah, we had the range sum query one. So now I'm on to 784 letter case permutation. So I'm just going to watch this video. And yeah, today's video will be a bit shorter just because the timings of when I started it. So yeah, I'm just going to mute my mic now and watch the video. Okay, so I've just finished watching this problem, and basically the problem is you have a string basically. So the example here is A1 B1, and you want to return all the permutations of the characters. So with permutations, you're just creating the order does matter, unlike combinations where the order doesn't matter. With the permutations, with these letters, so you have if we go back to this example, so you could have A1 B2, capital A1 B2, then A1 capital B2, capital A1 capital B2, and that would be the permutation, let's case permutation for this particular problem. So if I get the particular problem up here, okay, 748. Sorry, 784. leetcode. Right, so I'm also going to do this on paper. Just get a pen. So both of these solutions are very time complex. So it's 2 to the n in both time and space complexity, which is definitely not good. Okay, so I'm just going to enlarge this. So our first solution is basically where we go through each character in the string, and then we have a temporary array. So for each character in the string, we check if it's alphanumeric, and if it is, we go for O in output. So in our array of current permutations, we append the array that we've currently got plus the lower and plus the upper, and then at the end we assign output to temp. So, but if it's not alphanumeric, we just add for each value in the array, we just add the non-alpha character. Sorry, I shouldn't be saying alphanumeric, because if they're not alpha, they're going to be numeric based on the constraints. Okay, so I'm just going to write this out. So we have output equals this. So for C in S, and then we can do set up our temp variable. So then we do for, no, it should be the if step, yeah, my bad. If C dot is alpha, then we can do for O in output temp dot append O plus C dot lower. So there's two solutions to this one. I'm just going through the first solution, which is a bit more efficient in space complexity, because the other one's n plus 2n, but that still simplifies down to 2 to the n in the worst case scenario. So we can do temp dot append, and then we have the uppercase version, so plus C dot upper. Then if it's not alphanumeric, we go for O in output, temp dot append O plus C. I think that was it. Yep, and then we can assign output equals temp, because if we didn't do that, that would mean we just get a bunch of so if instead we appended it, it would mean we get a bunch of half completed strings. Oh yeah, then we got the return output. So I'm just gonna have the example with a A1, B2. So the array would be A. This would be A and also capital A. Then we move on to 1. This would be A1, A1. Then we go to B, A1, B, and then A1 capital B. And then 2, which is A1, B2, wait, hold on a minute, I didn't do the other one. Oh, my bad. Capital A, 1 lowercase b, then we got capital A, 1 uppercase b. And then we got A1, B2, A1, B2, A1, B2. Okay, so there we see, I don't know if you were able to make this out, but that's what we get. Okay, so now we go into the recursive one, which is same time complexity but different space complexity with n plus 2n, but ultimately it simplifies down back to, we only take the worst time complexity. For instance, if you had a program that has a for loop, then a for loop with a nested for loop separately of the first for loop, it wouldn't be O of n plus O of n squared, it would just be O of n squared, because that's what it simplifies back down to. So I'm just going to, okay, and try and get back to the iterative. So this is using backtracking, which is the current topic we're on in the video. And by the way, it's 2 minutes 20, no, sorry, 2 hours 20 into the Stony Code 70 leetcode problems in 5+ hours. Every data structure, full tutorial. So by the way, this is 5 hours, 27 minutes, and 19 seconds long. So this is iterative. I'm just going to label this. Then recursive. Using backtracking. So we initialize our result array. Then we have a nested function. So backtrack sub equals, then I equals 0, and we're going to just recursively call this function until the length of the parameter sub in the backtrack function is equal to the length of s. So that will mean that we've fully completed the string, if you understand what I mean. So yeah, if len sub is equal to len what's the input? S. Okay. Then we simply return res. Oh, okay. It's saying here we need to append sub to res. Oh yeah, we do. And we don't actually return res because we do that outside the function. And then we can do if s at I dot is alpha. We can backtrack this. So plus s at I dot swap case I plus 1. Then we can also call backtrack for the other case, which is sub plus s at I, and we don't swap the case this time, and it's still I plus 1. And yeah, we just call backtrack in function, and it does it for us. Then we just return res. Okay, yeah, okay, I see how that works. That's pretty intuitive. So I'm just going to go through it as well though. So A1, B2. So I'm going to have a counter here for I. So sub and I0. And then that would mean that, so A is alphanumeric, so, okay, well, it's going to be kind of hard just because you're doing it, because, but, you know, you can see how to, I'll just code it up here. So, we've got the res equals 0, no, is the array, then we've got def backtrack, and we've got the string here, and we got the index. So these are just defaulted. So here we can do if len string is equal to what? If len string is equal to len s, then we do res dot append string, because this is the only place where we actually append to the res array, and we just return, and then we can do if so we do string at index dot is alpha. If it is, then what we're going to do is we're going to call backtrack at the string plus string at index dot, is it case switch? Or swap case. And then index plus 1. String plus string at index, and notice here we don't have to do swap case because we're having both combinations, as it's a permutation of, there's only 2 different options that it could be. So yeah, and we just got to call the function backtrack and return res. Just trying to see if this is the same. Okay, let's just run it to find out. Oh. Okay. Okay, we can see that was a silly mistake. Oh. Index plus 1. Index out of range. Why is it out of range? String at index. Yeah, I'm going to quickly consult the original code on the YouTube video. Yeah, I can't see why it wouldn't work, because that's what we have here in the code. So, yeah, this is literally, I think it's identical to the code. But I made a silly mistake somewhere. S result open string index of range. Oh, it should be S. I was pulling it on the wrong one. Right, that is my blunder. Wrong answer. If S at index is alpha string plus swap case. The only problem is I can't see where we're adding to sub. If not sub. Because, dot pen string. Yeah, that's the only problem that I can see. But still, even if sub is not being added to, I don't get why. Oh, yeah, my bad. What was I thinking? Sub is obviously being added to here because we're recursively calling a function. But how is the index not? How is it never going to? Okay, I'm just going to leave this one because I've spent a lot of time on this problem. And I'll submit it so that it'll be stored in my storage. But let's see the next backtracking problem. Oops. I'm just going to mute my audio again. pardon me. So the next problem is 78 subsets. So what we want to do is return all the subsets of a certain array. And I think sorry, I got the hiccups. So in Advent of Code, I did this with a slightly strange approach. I did it, no, it was something to do with permutations, and I did it with binary. So, I basically, let me see if I can find it. Advent of Code. And I should just be able to search in this repository. Yeah, if I search binary, I should get it. Yes, so this is where I tried to use it. Let's see, I'm going to go to day 13. What is this? Okay, this was some obfuscated code. Anyway, it's integer to binary, so we're just turning this integer to binary, and this was my way of finding all these solutions. So let me find. Or actually use this. Would I not use it? Okay, string equals, and then if it's 0, then we'll do button A, else we'll do button B. And it was like to go through every, pardon me, every different combination, but I don't know if it will apply to this one. So let me see. Given into array nums of unique elements. Just trying to think how I'd do this. There's no possible. I mean, surely, how is there a more. How is there a better solution than just brute forcing it? Like, because you're going to get to the same amount of. I'm just going to quickly write up the brute force approach, because, to be perfectly honest, I don't see how you could get more time efficient than over n squared. To be honest. So. So if we're thinking about backtracking, let me just check my. Okay. So if we're thinking about backtracking, so we want to start off with an array of nothing, like we did to the problem before. And if I just look at the solution here, how could we change backtrack? So could we have stub instead of being a string, being an array? Okay, first of all, I'm just going to do the brute force solution. So for I in range then numbers, and we're going to have array if I is equal to j r dot append nums at I. Well, we may as well set this from I plus 1. The reason we're doing I plus 1 is because I will be I and we don't want them to overlap. Else R dot pen this should surely be minus 1 as well, so we don't have. Okay, dot append nums I to j. Wait, would this be right? I don't think it would, because yeah, it needs to be plus 1. And we'd get duplicates, wouldn't we? Actually, okay, I'm just going to return it. I'll see. Because it's always going to be greater, so. Okay, so we do want it to be like that. So we do get the duplicate values. We need to enclose this in an array.